Hello, this is Nick Hodges, the Delphi Product Manager, and this is another edition of Turbo Delphi Demos. Today I'm going to be discussing the debugger inside of Turbo Delphi. Now, a debugger is a tool built into the Integrated Development Environment, the IDE, whose job it is to show you your code while it's running. And you can incrementally run the code just line by line. You can peer in and check the value of variables. You can keep an eye on particular things, all during debugging, while you completely control the execution of your code. So I brought up TurboPad, which was an app we worked on in a couple of earlier editions of Turbo Delphi demos, and I'm going to use it to just show you some features of the debugger. Now, the first thing generally you do when you debug something is you set a breakpoint. Now, a breakpoint can be set by simply clicking in the gutter on a line in the IDE, in the code editor, where you want the debugger to stop when code execution arrives at that line. And so at its very most basic form, you can run an application, and then when you try to open a file, for instance, we'll pick a file, and then once the debugger accept event is fired on the file open event or action, the debugger stops and tells you that gives you this little blue arrow here on top of the red debugger symbol inside the gutter, and tells you that the code is about to execute this line of code. The debugger is about to execute this line of code here, the highlighted in this light purple color here. You also get a nice little item in the event log down here in the debugger that tells you that there's a breakpoint on that particular memory location inside the TurboPad exe process, and that the debugger has now broken at that point. You'll also notice that when you run the application, it also goes to the debug layout desktop, which gives you a bunch of information over here on the left and along the bottom, tell you information about the source code as it sits. The top one is the call stack. Now, the call stack is the list of methods and procedures and functions that have been called previously to get you to arrive at this particular point. So, for instance, right before this file open1 accept event handler was called, it was called by the common dialog action.doAccept method, and if you click here, double click on it, you can actually go back and see that code, and you can jump from code to code in your call stack to see where the code was actually called. And we could, of course, go right back to the point where we're execution point now. Below this is the watch list. Now, watches are specific variables that you can set that you want to keep an eye on, that you want to watch the value of. So, for instance, I could add a watch on the f file name variable, which we know before is the class that holds all of the file name information. And you'll notice now that we get a watch there. And the cool thing about watches is they are expandable. And you can see we can expand them out, and we can keep track of the two properties inside file name, which are f file name and the f is dirty properties. We can keep track of that information right inside the watch list. Now, if I want to execute code and go from line to line, I can either click step over or trace into. Now, the step over line will simply take us from one line to the next, like so. Now this line of code has been executed, and we are about to execute this line of code. And you'll notice that now that this particular line of code has been executed, the actual file name now contains a value, because it was the job of that line of code to get a value for the f file name property. And so now it has a value of the lorem ipsum.txt text that I've selected. And you'll also notice that if you now hover your mouse over that value, you'll get a little tooltip that will show you that value right there in the code editor. If I hover my mouse over the f file name value, you'll notice I even get an expandable tooltip there that'll actually drop down and expand and show me the data of the value of the f file name object itself. Now, that last time we stepped over the code. We can actually now trace into the code, which means that at this point, when I execute and I press trace into, it's going to go into this function called file exists. And now you notice that it's taken me, first of all, actually, to the get file name because if you'll notice that this code here has to retrieve the file name value before it can even call file exists. So now we can press the step over to go through to find the result, and now you'll notice that result is actually available to us in the local variables window. The local variables window, of course, holds values for all of the variables that are local to the current routine, in this case self, and then also in this case result. Since result is local to this function text file get file name. And then I'll continue to trace into, and you'll notice it jumps into the sysutils unit, and it actually will now execute the code in sysutils. I don't want to get too far into sysutils because you can then get really down into the nitty-gritty if you like. But we'll continue to step over items in sysutils, and it'll take us eventually back to file exists clearly evaluated to true. So now we're executing the line where we're going to load this file up. So now you can either step into or step over those particular values in the in your code using the trace into, which is F7, or also the shortcut key is function key 7, or the step over, which is F8. Now you notice I just set the dirty property, so now that we can, well, actually the optimizer has optimized out all of the values as we do the return, and now we can continue to run the application at this point by pressing the run button, and now you see that the application has loaded up that text file for you. So that's a quick look at the debugger. Now some things to note are, if you right click on a breakpoint, you can set breakpoint properties, and you can set some properties on a breakpoint. For instance, perhaps you want to, the breakpoint you have is inside of a loop, but you don't want to have it break on every single instance of the loop. You just want to have it break on a certain number. You want to go by that breakpoint a certain number of times, so you can push, you can type in 10, and then that breakpoint will be passed by 10 times before it stops on that, before the debugger stops on that breakpoint. In addition to that, you can also set a condition on the breakpoint. So for instance, you can set, for instance, the length. You can check the length of the file name, and if it's less than 4, then the breakpoint will break. If it's greater than 4, then the breakpoint won't break. And since the file name value always defaults to untitled.txt, if you recall correctly, this breakpoint probably would never fire. But now if we run it, you'll notice that if I open it up and I select our trusty lorem ipsum, you'll notice that the breakpoint doesn't fire, simply because the length of file name never ends up being less than 4. So you can have breakpoints set on conditions. You can actually also, as you might note here, group your breakpoints together and then turn groups on and off and whatnot. You can have actually ignore certain exceptions and handle subsequent exceptions. You can do some logging and all that type of stuff of your exceptions there. Generally that's more advanced topics, but they're there if you want to use them. Okay, I'll just set an empty breakpoint here, and once again we'll run the application and go to that breakpoint, and we'll check a couple other things out that you can do. Now you notice down here that every time there's an event that takes place, you get a report back about modules being loaded and unloaded. You can actually jump from breakpoint to breakpoint down here as well if you select the breakpoint list. And there's even information about different threads that are involved with the application. There's some other things you can do as well with the debugger. For instance, one of the things that's common to do is to bring up the, it's over here. We can say right click and select debug and go to inspect. And this inspector actually is a little window that actually will pop up and inspect the specific information about the specific items, give you a little object inspector look of different items inside of the IDE. So for instance, we've selected filename.filename, and you get it as value set as untitled.txt. If we were to scroll back a little bit and select debug inspect, you'll notice now we get a more interesting look at a class, and that class has two properties. It also has methods attached to it. You can look at the methods, and these are actually internal addresses of where the method pointers point to and all that stuff. And you can set and check the properties. For instance, the isDirty property is true. It also has it tells you what the read and write methods are. If you select here, you can actually change the value of these things in memory if you like to, if you want to be messing around with the internal memory structure of your application. Not a common thing to do, but sometimes you might want to do that. And another thing you can do, of course, is select the debugs, and you can I'm sorry, once it did it again, debug, and then you can also call evaluate modify, which brings up a little window that allows you to actually type things in and ask for what their current values are at that particular time. So for instance, I can type is dirty here and it'll tell me true, and if I just type in a file name, it'll give me a little class view of that. I can also select, say, main form.caption, since main form.caption is in scope at this point, and it'll tell me pieces of information about the main form's caption. I can actually click on value for watch and it'll automatically add a watch to me for me to that value. You notice too, as a watch window, I can turn watches on and off as I'd like, so then perhaps you don't want them evaluated during the execution of your code. And finally, the last thing I'll show you here with the debugger is the CPU view. You can go view CPU, and now of course at this point it's getting really down to the metal. You're looking actually at the exact lines of assembly code that are being called by each individual line. This is basically the output of the compiler. If you want to take a look at down to the metal piece of information about the actual executable machine code that your application is running, you can take a look in here, and you can of course look at the registers, all the registers and all their values. You can get a hexagonal view of exactly what's going on in your code. So right at this point, you're down to the metal, looking at the very, very lowest level of your code, and you can actually hit F8 to step through each line of the assembly code as they are executed, and get a real low-down level look at exactly what your application is doing. I personally don't use this a lot because I don't read assembler, but if some of you out there do, there you go. You can read the assembler. And of course I'm hitting F8, and that'll step me through the application one by one. Many times you just want to find out where code goes. The F8 will tell you that. And F7, of course, as you step into as opposed to over each line of code. And of course, as you're doing that, you can highlight each individual variable here, and the debugger will tell you strict pieces of information about about the value. Here you can see that use default app is false. Okay, bring us back to the baseline here, and just a couple of other things that you can do with the debugger. You noticed earlier that we actually stepped into the sysutils unit, and that was because our project options has use debug DCUs set to true here. I went to, let's do that again just to show it, project options on the compiler item in the tree view here. If you select use debug DCUs, that will allow you to step into the VCL source code. So for instance, if I put the breakpoint here on file exists, and I run and I hit that breakpoint, and then I hit F7, we'll first get the file name, that's our code, but you'll notice that then it steps into the sysutils unit. However, if I close this app up, go to the project options, deselect use debug DCUs, and then I'll actually build the project again to use the new DCUs as opposed to the old ones. So now when I run it, open up the file, hit the breakpoint, and now I'm hitting the step trace into call. You'll notice that it will step into the get file name, but then it immediately goes back to the file open except our code and doesn't step into the VCL source code. So that's a way that you can either control either going into or not going into the VCL source code. Sometimes you want to check to see what's going on inside the VCL, sometimes you don't, and of course you have control over that. So that's a quick look then at our debugger in Turbo Delphi, and thanks for your attention, and we'll see you next time.